All right, good evening everyone and welcome. In this session, we'll be going over Cyber for Industry 4.0. What is CPS protection anyway? So without further ado, let's introduce Sean and Gilson.
Go ahead.
All right. Hi everyone. My name's Sean Ear, Global Head of Cloud Alliances for Claroty.
Yes, and hey everybody, my name is Gilson Wilson, and I lead the security competency at AWS for all of our GSI and NIS123 partners, and I also lead initiatives like our Secure and Resilient Migrations program here at AWS. So, Sean?
Awesome. So we're at the world's premier cloud security conference. This conversation is a talk about CPS protection, a primer level introduction to CPS protection for cloud security professionals like yourselves. So this is a term that has been increasing in importance lately. Let's start by defining it. So Gartner has brought this term to the forefront to provide a unified approach to thinking about 4 different categories of technology that have been around for a while and have required security for a while, but under this new term, cyber physical systems. In a nutshell, CPS is where the digital world and the physical world come together. So the first category of technology included under CPS are IoT devices. This is equipment and devices that were designed for connectivity. They've been around for about 10, maybe 15 years. Designed for connectivity, but not necessarily designed with security in mind. Second category, operational technology, or OT. So there's IT, and then there's OT, information technology and operational technology. Here we're talking about devices and equipment and assets that are older than IoT, things that were designed to be deployed in air-gapped environments like manufacturing facilities, critical infrastructure, oil and gas. We're talking about HMIs and PLCs controlling large pieces of industrial equipment like conveyor belts and smelters. Third category, medical devices, sometimes referred to as IoMT, Internet of Medical Things. Medical devices like infusion pumps and MRI machines and nurses' workstations aren't typically referred to as OT in the healthcare industry, but the approach to securing them is similar. And then the fourth category, a little bit newer, building management systems. When you think about modern construction and you think about efficient buildings with connected HVAC and fire suppression and intelligent lighting, access control and security cameras, all the smart technology inside of modern buildings. Elevators. Elevators used to just have a dumb up button and a down button. Now you go over, you hit a touch screen, you indicate which floor you want to go to. All of that equipment controlled digitally now. And everything that can be controlled digitally can be attacked digitally. When we're talking about CPS protection and CPS risk, the risks are different. We're not just talking about risks to data anymore. We're not talking about hacking an email server, exfiltrating PHI, or publishing credit card numbers on the dark web. We're talking about taking over an HMI, human-machine interface, and literally affecting the controls on a machine that changes things in the physical world. So over here we talk about a hacker, an adversary, causing equipment to exceed its normal operating parameters, taking over the security controls and disabling them, changing the set points. The set point on a machine is how fast, how high, how hot, how much pressure, right? Cranking it up to 11 and then shutting down access so the admins can't get in and fix it. Many examples of adversaries coming after physical systems and wreaking havoc in the physical world. One of them that we might pick out, the Ukrainian attack, right? Ukrainian affiliated hackers attacked the sewage systems in Moscow. And without firing a shot or setting off a bomb, they destroyed 87,000 smart alarms underneath the city, disabling the sewage system. That type of attack is sabotage. It's not just espionage anymore. And there are many such examples. So, in February, Gartner issued their very first Magic Quadrant for this space. Reflects the growth in the problem and also the maturity of the vendors that have come out with solutions to address the problem. They profiled 17 vendors, 5 appeared in the top right quadrant, and we're very proud to say that Claroty was rated highest for ability to execute and furthest to the right for completeness of vision. As much as we are proud of that placement, it's the feedback from our customers, public feedback, and also anonymous feedback collected by analysts that we're very, very proud of. So why is this happening now? Why are we seeing this sudden growth in cyber attacks on physical equipment, and why did Gartner recognize the growth in this market now? Well, we're living at the intersection of 2 historic trends. Before getting into that, let me take a step back and describe some of the important differences between IT environments and CPS environments. First of all, inside of a company, the people responsible for IT and the people responsible for, say, the factory, the automation systems, the critical infrastructure, it's different teams. Different teams with different cultures, priorities, and protocols for how they work. Secondly, the equipment you will find on these different networks in these environments, radically different. In a data center, for an IT organization, it doesn't matter whether you're a healthcare org, a manufacturing org, a critical infrastructure, your data center kind of looks the same. You're all buying the same servers and you're all buying the same laptops. But in the line of business, it's wildly different, right? There are so many vendors with so many different pieces of equipment. The infusion pump you find in a hospital will never appear in an automobile factory. The conveyor belt in that factory won't appear in an oil field. The centrifuge that you find in a drug manufacturing facility won't appear in either of those, right? So tremendous range in the equipment that needs to be protected. And most of this equipment, the amount of, we talk about the shortage of security practitioners on the IT side, it's far worse in the OT side. We're talking about obscure equipment that very few people know how to deal with, so when something goes wrong, you're often required to call in the vendor, the OEM manufacturer of that equipment, to troubleshoot it. On the IT side, cybersecurity is a very mature industry. In addition to all the vendors we have here, there are thousands of cybersecurity vendors offering solutions and tools to help companies secure IT. On the OT side, the tools are far fewer and far less mature. Claroty, the market leader in the space, we just celebrated our 10-year anniversary. What this means is that for the longest time, CPS security relied on the air gap. That was the predominant strategy for securing the line of business. That's changing now for 2 main reasons. The first is we had COVID a few years ago, right? COVID meant that people couldn't get on planes and travel. And so if equipment in a facility required expert attention, your technician, your maintenance provider couldn't physically get on a plane and come and plug in their laptop and address the issue. And so customers opened up remote access in an insecure way, basically punching a hole through their firewall, through the air gap, which obviously increased the surface area. The second major trend is the term, I'll only use it once here today, AI and ML, right? Everyone wants more connectivity to the shop floor. Everyone wants to implement industrial data fabrics. Everyone wants to use predictive maintenance on IoT data or drive worker safety and quality control in the facility in real time using machine vision. All of these transformational projects require eliminating the air gap and connecting the shop floor to the cloud. Both of these 2 trends increase the surface area for an attack. It's also the reason that Claroty and AWS have such a deep strategic partnership. I'm about to wrap, and we've said so much about how CPS protection and CPS assets are so different from IT assets. They actually have some things in common. You as security practitioners already have a particular framework of thinking about security that you can apply to thinking about CPS protection. It all starts with asset visibility. Just like in the cloud, just like deploying a CSP, right? You can't protect what you can't see. You have to start by identifying all of the assets that you have in your environment and deciding how important they are, what their value is and what the disruption could be. From there, you move on to exposure management, understanding what's connected to the internet that shouldn't be, what has a default password from the manufacturer that shouldn't, what has a known exploited vulnerability that needs to be addressed. From there, you move to network protection, implementing segmentation in order to contain any potential breach. And finally, proactive threat detection, looking at patterns of behavior, identifying anomalous behavior, and then investigating potential threats. In addition to that standard flow, remember, we're dealing with physical assets in a physical part of the world. It's not just the cloud, and so you have to open up remote access in a secure way, which is enterprise-grade, zero trust-based, loggable, permission-based, and time-bound. And those are the basic building blocks of CPS security. Wilson?
Thank you. Thanks, Sean. And like Sean mentioned, it's probably interesting to see when we have CPS, so essentially cyber physical systems and operational technology, that's in a cloud security conference here today, because we're all about the cloud. But it would surprise you sometimes to know that there's a lot of services and technologies that AWS does offer, which makes the connection. So one of the things that I wanted to start off with was in terms of breaches by industry that we see today. And all of last year, if you look at most of it, yes, you see the usual, financial services and insurance companies, etc. However, if you look at the bottom quadrant, other than financial services, almost all of them have one thing in common, which is industrial systems, operational technology, signal processing, and things of that nature. On the public sector, education and healthcare, I would say a lot of state and local government and federal organizations as well fall in that category in terms of a significant amount of hacking attempts and vulnerabilities that have hit for critical infrastructure as well, and so that has peaked over time. And like Sean had mentioned earlier, outside of CPS, security still is considered as the #1 detriment for anybody, or at least hesitation in moving workloads into the cloud. And CPS is no different as well, especially when it comes to things like when you want to move projects from POC to production, you get into a sense of where security falls in to actually slow down the adoption of cloud. And this is just based on stats that we have gleaned over time from several customers. And by incorporating security right from the get-go, like security by design, you would actually be able to deploy workloads into the cloud much faster, and you'd also have higher success rate for your projects as well. Now, what are the challenges? Sean touched a little bit about the differences between IT and OT, but what are the challenges that you see in terms of security? One of the things, and if you've seen my other talks as well, when I talk about security in general, you will see that a lot of it is still doing the basics in terms of data security, in terms of network security, etc. But when you come to cyber physical systems, some of the challenges are things like performance and availability, right? I don't know why this keeps going forward. A lot of stuff that we do with CPS systems, especially, are essentially real time. They have to have pretty much 100% uptime for the most part. In terms of any kinds of outages and things like that, you have flexibility when it comes to IT, but with OT, there's usually like weeks of planning. There's also months of planning that actually can need to be happen for any kind of outages and things like that have to come in. In terms of resource constraints, this is a big one between IT and OT. A lot of the devices actually don't have enough compute and memory to hold things like encryption libraries and security capabilities and applications. They weren't essentially designed for that. Some of the newer ones absolutely are, but there's still a lot of industrial systems that don't have that capability. And so from a communication standpoint, they're usually mixed from IT and OT as well. And I think the only other thing that I would raise over here is, let me come back. For some reason it keeps going forward. The only other thing that I would raise over here is in terms of system operation and operating systems that are kind of known to all of us in the IT space and how they're deployed versus some of the automated tools and there are automated tools already that we use in our, for patch management and operating system management as well versus proprietary hardware that might be there for signals and other devices. So when it comes to securing cyber physical systems, what do we really mean, right? I mentioned earlier, keeping it simple is very important. Doing the basics is still having good discipline. Having good cyber discipline still stands foremost as some of the things that you can do to protect yourself from cyber challenges for IIoT and OT devices in general. So the first one, secure all layers. Defense in depth is still being leveraged. Establishing zero trust boundaries. Securing network connections. So all the usual encryption. I think Edward Snowden said it at one point where he said that encryption is essentially the defense against dark arts for information technology, and that still stands true to this case for secure protocols. The one thing that I will bring up over here is shrinking the attack surface. Many of these devices do have a significant amount of services that are either switched on or capabilities that are switched on in the system. And what you want to do is not only harden, but eliminate any of those things that can be a potential threat to the attack surface, or in fact, increasing your attack surface. And what's important now is that many organizations have their industrial manufacturing, critical infrastructure hooked up to the cloud and other IT services because they need to get that kind of observability. They need to use that for analytics. Maybe they want to hook it up to their supply chain ordering mechanisms and things of that nature, basically to understand when the system is failing or needs to be replaced, for example. And every time you do that, you're increasing the attack surface significantly. And so by following the policy of shrinking that as much as possible, doing the analysis, it's very important to keep that in mind. The last thing I want to highlight over here is having a resilient response plan. Now, what does that mean, right? The key thing here is we always advise and coach on having a battle plan to manage your response plan, because breaches by themselves are never disasters. It's your response to a breach that can significantly take your organization in one path or the other. And we continuously talk about running simulations, red, blue team, purple teaming exercises. We practice on continue to do it, not till you get it right, but continue to do it till you can't get it wrong. It's something that we've copied from different coaching manuals, but running attack simulations on how you can recover very quickly. Cyber resilience is now pretty much the key to success in managing not just IT environments, but IT and OT environments as well. So what does this essentially look like from an architecture perspective? So I'm just going to go through like an example architecture of what it would look like. Everything from like and this is a real example with names removed, obviously, but starting from on-premises manufacturing network with different types of devices, either they have networks or they don't. They have their own secure protocols that they use for communication, etc. And this is essentially what we would consider layer one. And one of the things that we mentioned was how does AWS kind of fit into this offline mood of operation, since we're actually a cloud-first company. If you think about services, like not many people know this, but there's services like that we run on the edge. There's AWS IoT, there's AWS Greengrass, and all of these services are intended to help you run different services offline without needing connection to the internet at all. And so you can run compute, you can run storage, you can run all of that offline within your own premises. And as and when you require access to the internet to help you secure all of those and collect signals, so you could use something like AWS Greengrass to work with all of your sensors, collect all that signal, collect all of that information, and then feed it up to the AWS cloud, where you can use it for more intelligent processing and supply chain management, and maybe repairability and maintainability, et cetera. And as you can see, and at that point, you can leverage things like AWS Guard Duty and AWS Security Hub to actually pull that information in to help you further keep all of your entire infrastructure holistically secure. So thank you very much for listening. Sean, do you have any final thoughts?
Yes, thanks everyone. If you're interested in learning more, Claroty is at booth 321. Very easy to find us. If you work for a company in consumer goods, manufacturing, heavy industry, healthcare, life sciences, and you aren't already working on OT security, chances are it'll eventually enter into your life because CISOs and IT teams are being told they have to protect the company from threats everywhere, not just IT.
Thank you, everybody.
Thanks, Wilson.